Welcome to a lesson on the interior and exterior angles of a triangle. The goals are to define interior and exterior angles of a triangle, and then also state several theorems involving the exterior angles of a triangle. The interior angles of a triangle are the angles inside the triangle formed by the sides of the triangle. So angles 1, 2, and 3 are the interior angles of this triangle. The vertices are the points where the sides of the triangles meet. So the vertices are A, B, and C, and vertex is singular for vertices. So we have vertex A, vertex B, and vertex C. The exterior angles of a triangle are the angles that form a linear pair with the interior angles by extending the sides of a triangle. There are actually two sets of exterior angles based upon which sides you extend. What I mean by that, if we take a look at vertex C, notice the triangle on the left here, we extended side BC through vertex C. And notice on this triangle here, we extended side AC through vertex C. So if we continue this pattern, you can think of these extensions going counterclockwise, and these extensions are clockwise. So again, if angles 1, 2, and 3 are interior angles, then angles 4, 5, and 6 would be exterior angles for this triangle. Notice they form linear pairs with the interior angles. And looking at this triangle here, angles 4, 5, and 6 would be the exterior angles. Again, they form linear pairs with the interior angles. And it really doesn't matter which sides you extend, because angle 4 is congruent to angle 4, angle 5 is congruent to angle 5, and angle 6 is congruent to angle 6. Let's take a look at a couple of example problems. Here we want to determine the measure of the indicated angles. So there's a couple things to remember. First, the sum of the interior angles of a triangle will always be 180 degrees. And now we also know that the exterior angles form a linear pair with the interior angles. So looking at angle 2, we know the measure of angle 2 plus 138 degrees must be equal to 180 degrees because they form a linear pair. So if we subtract 138 from both sides of this equation, we know that the measure of angle 2 must be 42 degrees. And in a similar way, the measure of angle 1 plus 94 degrees must equal 180 degrees. So if we subtract 94 from both sides, the measure of angle 1 will be 86 degrees. And now looking at the interior angles, we know the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 must equal 180 degrees. Well, the measure of angle 1 is 86 degrees. The measure of angle 2 is 42 degrees. We don't know the measure of angle 3, but we know the sum is 180 degrees. So 86 plus 42, that's 128. If we subtract 128 from both sides, we'll have the measure of angle 3, which will give us 52 degrees. And then to determine the measure of angle 4, we know that angle 3 and angle 4 form a linear pair. So 180 degrees minus 52 degrees will give us the measure of angle 4. That'll be 128 degrees. Let's just take a moment and sum the exterior angles of this triangle. You have 94 degrees, 128 degrees, and 138 degrees. This is going to be 20, carry the 2. It's going to be 11, 13, 16, carry the 1, 360 degrees. Notice the interior and exterior angles form 3 linear pairs. Well, 3 times 180 degrees would be 540 degrees. Then if we subtract out the sum of the interior angles, which is always 180 degrees, we would get 360 degrees, which matches the sum of our exterior angles. We'll come back to this idea later on in the video. Let's take a look at another example. This one will go a little bit quicker We know that the interior and exterior angles form a linear pair, and therefore their sum would be 180 degrees. So 180 minus 124, that's going to give us 56 degrees for this angle here. Over here we'd have 180 degrees minus 95 degrees, that'll be 85 degrees. And then again, we know the sum of the interior angles would be 180 degrees. 56 degrees plus 85 degrees, that's going to be 141 degrees. So 180 minus 141 is going to give us 39 degrees here. And then angles 1 and 2 form a linear pair. So 180 minus 39 is going to give us 141 degrees for angle 2. Okay, let's talk about a couple theorems that involve exterior angles, and then we'll prove them in the next couple of videos. The sum of the exterior angles of any triangle, as well as any polygon, is always 360 degrees. So again, what I was trying to point out earlier is that we know that the interior and exterior angles form three linear pairs, and therefore the sum of angles 1 through 6 would be 180 degrees times 3, which is 540 degrees. And then we also know that the sum of the interior angles of any triangle is 180 degrees. So if we take 540 degrees, subtract out 180 degrees, this will always be 360 degrees. So the sum of the exterior angles of a triangle will always be 360 degrees. And this is also true for any polygon. Before we talk about the last theorem, let's define remote angles. The remote angles are the two angles in a triangle that are not adjacent angles to the specific exterior angle. So if we pick one exterior angle, let's say this angle here, the two interior angles not adjacent to angle 1 would be angle 2 and angle 3. Angle 2 and angle 3 are the remote angles to angle 1. And these angles have a special relationship. The exterior angle theorem states that the sum of the remote interior angles is equal to the non-adjacent exterior angle. So again, if this is angle 1, this is angle 2 and 3, the remote angles, the measure of angle 2 plus the measure of angle 3 will equal the measure of angle 1. Let's talk about why that is. If we call this angle 4, so the measure of angle 1 plus the measure of angle 4 equals 180 degrees. We also know the sum of the interior angles is 180 degrees. So we know that the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 180 degrees. Well, if we solve this first equation for the measure of angle 1, the measure of angle 1 is equal to 180 degrees minus the measure of angle 4. And if we solve this equation for the measure of angle 2 plus the measure of angle 3, we would have the same thing, 180 degrees minus the measure of angle 4. So from this we can conclude that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. We'll take a look at a more formal proof of these two theorems in the next two videos. Thank you for watching.